In New England, a licensed technician generally has 30 days to update the license when a new code or change is put into effect. It's essential to understand the implications of code changes on your work and to ensure that you adhere to the latest regulations. This involves several steps that a technician should undertake to remain compliant. Firstly, when a new code or change is announced, technicians should immediately seek out resources to understand the specifics of the update. This might include attending workshops, seminars, or webinars offered by professional organizations or licensing boards. These educational opportunities often provide detailed explanations of the new requirements and how they differ from the previous code. Secondly, it's crucial to review official publications and documentation related to the code change. These documents, often available from regulatory bodies, provide the authoritative source of information and should be carefully studied to ensure a comprehensive understanding of the new requirement. Thirdly, technicians should assess how the code change impacts their current practices and procedures. This might involve re-evaluating standard operating procedures, updating checklists, or modifying the way certain tasks are performed. It's important to identify any areas where adjustments are needed to ensure compliance with the new code. Fourthly, technicians should update their knowledge and skills through continuing education. Many licensing boards require technicians to complete a certain number of continuing education hours to maintain their license. These courses can cover a wide range of topics, including code changes, new technologies, and best practices. Completing these courses not only helps technicians stay current with the latest requirements, but also enhances their professional development. Fifthly, technicians should document their efforts to stay current with code changes. This might include keeping records of workshops attended, courses completed, and official publications reviewed. These records can serve as evidence of compliance in the event of an audit or inspection. Sixthly, it is important to understand the specific requirements for updating your license in New England. This may involve submitting an application form, providing proof of continuing education, and paying a fee. The licensing board will review the application and verify that all requirements have been met before issuing an updated license. Seventhly, technicians should network with other professionals in the field to share information and best practices related to code changes. This can involve attending industry events, joining professional organizations, or participating in online forums. By connecting with peers, technicians can gain valuable insights and support in navigating the complexities of code compliance. Eighthly, technicians should seek clarification from regulatory bodies when needed. If there are any aspects of the code change that are unclear or confusing, it's important to reach out to the licensing board or other relevant authorities for guidance. They can provide authoritative interpretations of the code and help technicians understand how it applies to their specific circumstances. Ninthly, it's crucial to understand the potential consequences of failing to update your license within the 30-day time frame. These consequences can include fines, suspension of your license, or even legal action. Therefore, it's essential to take proactive steps to ensure that you comply with the requirements and maintain your license in good standing. Tenthly, technicians should consult the National Electrical Code, or NEC, which is a widely adopted standard for safe electrical installations. This code is updated every 3 years, and it contains detailed requirements for a wide range of electrical systems. Technicians should familiarize themselves with the latest edition of the NEC and understand how it applies to their work. Let's discuss some specific examples of code changes that might require technicians to update their licenses. One example is changes to the requirements for ground fault circuit interrupters, or GFCIs. These devices are designed to protect people from electrical shock, and they are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Code changes might expand the areas where GFCIs are required or modify the performance requirements for these devices. Another example is changes to the requirements for arc fault circuit interrupters, or RFCIs. These devices are designed to protect against electrical fires, and they are required in certain circuits that serve living areas. Code changes might expand the circuits where RFCIs are required or modify the performance requirements for these devices. A further example involves updates to the requirements for wiring methods. This includes the types of cables and conductors that are allowed to be used in different applications. Code changes might introduce new wiring methods or modify the requirements for existing wiring methods. It's also important to consider changes to the requirements for electrical equipment. This includes items such as panel boards, transformers, and lighting fixtures. Code changes might introduce new requirements for the design, installation, or testing of electrical equipment. To ensure compliance, technicians should stay informed about the specific code changes that apply to their work. They should also participate in continuing education activities and seek guidance from regulatory bodies when needed. By taking these steps, technicians can maintain their licenses and ensure that they are providing safe and reliable electrical services. Consider a scenario where the NEC introduces a new requirement for surge protection devices, or SPDs, in residential buildings. Previously, SPD were not mandatory in all residential installations, but the updated code now mandates the installation to protect sensitive electronic equipment from voltage surges. In this case, a licensed technician in New England would need to update the knowledge regarding SPD, including their proper selection, installation, and testing procedures. They would also need to ensure that their license reflects their understanding of this new requirement. Let's look at some NEC articles and their potential impact on technicians. NEC Article 210.12 addresses arc fault circuit interrupter protection. If there are changes to this article, such as expanding the locations where size are required, technicians need to be aware of these changes to ensure that they are installing size in the correct locations. Similarly, NEC Article 250 covers grounding and bonding. Any changes to this article, such as new requirements for grounding electrode systems, would need to be understood and implemented by technicians to ensure the safety and reliability of electrical systems. NEC Article 310.15 deals with ampacity of conductors. If the code changes the way ampacity is calculated or introduces new requirements for conductor sizing, technicians would need to update their knowledge to ensure that they are using the correct size conductors for the intended application. Another critical area is NEC Article 406.4, which covers receptacles. Any changes to the requirements for receptacles, such as tamper-resistant receptacles in dwelling units or weather-resistant receptacles in outdoor locations, would need to be understood and implemented by technicians. NEC Article 408.36 addresses overcurrent protection. If there are changes to the requirements for overcurrent protection devices, such as circuit breakers or fuses, technicians would need to be aware of these changes to ensure that they are providing adequate protection for electrical circuits. Consider a situation where a technician is working on a commercial building and the NEC has been updated to include new requirements for energy efficiency. These requirements might include installing occupancy sensors for lighting control or using high-efficiency lighting fixtures. The technician would need to be aware of these requirements to ensure that the building meets the latest energy efficiency standards. Furthermore, technicians need to be aware of any local amendments to the NEC that have been adopted by the state or local jurisdiction. These amendments might be more stringent than the NEC requirements, and technicians would need to comply with these local requirements as well. For example, a local jurisdiction might require the use of specific types of wiring methods or the installation of additional safety devices. It is also important for technicians to understand the role of inspections in ensuring code compliance. Electrical inspections are typically conducted by local authorities to verify that electrical installations meet the requirements of the NEC and any local amendments. Technicians should be prepared for inspections and be able to demonstrate that their work complies with the applicable codes. They should also be aware of the procedures for correcting any code violations that are identified during an inspection. In addition to technical knowledge, technicians also need to have strong communication skills. They need to be able to effectively communicate with customers, contractors, and inspectors to explain code requirements and address any concerns. They also need to be able to document their work accurately and maintain records of inspections and permits. To further illustrate the importance of staying current with code changes, consider a scenario where a technician is installing a solar photovoltaic or PV system. The NEC has specific requirements for the installation of PV systems, including requirements for grounding, overcurrent protection, and disconnecting means. If the technician is not aware of the latest code requirements, they could make mistakes that could compromise the safety and reliability of the PV system. For example, they might not properly ground the system, which could create a shock hazard. Or they might not install the correct size overcurrent protection devices, which could lead to a fire. In addition to the NEC, there are other codes and standards that technicians need to be aware of. These include the National Fire Alarm Code, or NFPA 72, which covers the installation of fire alarm systems, and the National Electrical Safety Code, or NESC, which covers the installation of electrical power and communication lines. Technicians should familiarize themselves with these codes and standards and understand how they apply to their work. Ultimately, the responsibility for staying current with code changes rests with the individual technician. They need to take proactive steps to educate themselves about the latest requirements and ensure that their work complies with the applicable codes and standards. By doing so, they can protect the safety of themselves, their customers, and the public. Also consider voltage drop calculations, which are critical in ensuring the proper performance of electrical circuits. Code changes might introduce new requirements for voltage drop, such as limiting the maximum voltage drop allowed in branch circuits or feeders. Technicians would need to understand these requirements to ensure that they are designing and installing circuits that provide adequate voltage to the loads they serve. Understanding how to properly bond electrical equipment and systems to ensure a safe path for fault currents is crucial. Code changes might introduce new requirements for bonding, such as using specific types of bonding conductors or connecting bonding jumpers in a certain way. Technicians would need to understand these requirements to ensure that they are properly bonding electrical equipment and systems. And lastly, understanding requirements for selecting and installing overcurrent protection devices, such as circuit breakers and fuses, to protect electrical circuits from overloads and short circuits is necessary. Code changes might introduce new requirements for overcurrent protection, such as using specific types of circuit breakers or fuses or coordinating overcurrent protection devices to prevent nuisance tripping. Technicians would need to understand these requirements to ensure that they are providing adequate overcurrent protection for electrical circuits.